We are now at question 10, part A, and in question 10, we are given this circle, center O, RQ here is a diameter, and it passes through the center. PM and PN are tangents to the circle, and so the length of PM is equal to the length of PN, and we are told that angle MPN is 54 degrees. That's the angle here between the two tangents, is 54 degrees, and also angle RQM is 20 degrees inside the circle here. Alright, and that's the information, and then we're asked a series of questions. Now the first part wants us to calculate angle MRQ, and we have to give reasons for our answer. Now angle MRQ is the angle right here. So let's call that angle theta and show that angle theta on the diagram. And so this theta here is angle MRQ. And so we want to find this angle. Now this angle is an angle in this triangle. And this triangle is going to be a right angle triangle because this is a diameter, and the angle subtended by a diameter at the circumference is a right angle. But let's remove this line so we can see that triangle more clearly. And this is it. What I'm saying is that angle RMQ, M at the circumference here, this angle here is subtended by this diameter, and that angle is equal to 90 degrees because angle subtended by a diameter at the circumference of the circle right here is 90 degrees. And so we can show that that angle is 90 degrees. And because this now is a triangle, we can say total angles in the triangle is 180 degrees. And that's the basis on which we will calculate the angle theta. This is it. Total angles in triangle MQR now is 180 degrees. And so these three angles must add up to 180 degrees. And from that calculation, we see that theta, the angle that we want, is 70 degrees. Since this angle is 90 degrees, these two must add up to 90 degrees. And so this angle is 70 degrees. And so the angle that we want, angle MRQ, is 70 degrees. And that's the answer for part 1. Let's move down to part 2. Now part 2 wants us to calculate angle PMR. That's angle PMR. That's the angle between the tangent here and the chord MR. Let's call that angle alpha and show alpha on the diagram. And this is it. Angle PMR is this angle here. And as I said, it's the angle between this tangent and this chord. Now the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference here in the alternate segment of the circle. And so if we move again that line, we can see that relationship more clearly. This angle alpha is between this tangent and this chord, and this chord is subtending an angle at this circumference here of 20 degrees. And so that angle alpha is equal to this 20 degrees here, and this is it. Angle PMR, which is the angle we want, is equal to angle MQR, which is 20 degrees. And so that angle that we want, angle PMR alpha, is equal to 20 degrees, and this is the reason. The angle between a tangent PM and the chord MR, that's the angle here, is equal to the angle subtended by the chord MR at the point Q here on the circumference. Q is on the circumference in the alternate segment of the circle, meaning in the segment of the circle alternate to the angle alpha. So that's on this segment of the circle. And so alpha is equal to 20 degrees. And let me just read the reason again. The angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of the circle. And that's the reason why alpha is equal to 20 degrees. And so we can write the answer for part 2. Angle PMR is 20 degrees. Let's move down now to part 3. Now part 3 wants us to give the angle PMN. angle PMN is the angle here between PM and MN, the angle through here. And so we will call that angle beta and show that angle beta on the diagram by removing some of that information. So this is the angle that we want now. The angle PMN is this angle here between this tangent and this chord. Now this chord completes a triangle formed by the two tangents, and the two tangents are equal distances from the point P. And so this triangle PMN is an isosceles triangle, and we can use that fact to calculate beta. Let's go through the explanation. And this is it. The tangent PM is equal to the tangent PN. PM is equal to PN, and therefore this triangle PMN is an isosceles triangle. And we know that since this angle is beta, then this angle also is beta, because these two angles now form the base of this isosceles triangle. And so we can go ahead and say that angle PMN is equal to angle PNM. And so angle PNM is also beta. And so we can show that on this diagram. And so now we have the three angles in this triangle, 2 beta and 54 degrees, and the total angles in the triangle must be 180 degrees. And so we can say that total angles in triangle PMN is 180 degrees, and so these three angles must add up to 180 degrees, and we can show that. So it's 54 degrees plus 2 beta, 54 degrees plus the 2 beta angles here equals 180 degrees. And if we simply divide through by 2 to simplify, we end up with 27 degrees plus beta equals 90 degrees. And now to find beta, we simply subtract 27 from 90 degrees, and we end up with beta being equal to 63 degrees. And so we have found the angle that we wanted. And this is it. Angle PMN, which is beta, is equal to 63 degrees. And that's the answer for part 3 of question 10A. Let's move down now to question 10B. Now question 10B gives us this diagram along with this information. It says the points A, B, and C are on horizontal plane. So this triangle is on the horizontal plane. So that's an horizontal triangle. And then TA is a vertical lighthouse. So this is a vertical lighthouse. So this is a three-dimensional situation. We have a horizontal plane, so these are horizontal lines, and this is a vertical line. So this is a three-dimensional diagram, and since this is vertical and these lines are all horizontal, the angle between this vertical and this horizontal is 90 degrees, and the angle between this vertical and this horizontal line also is 90 degrees. It does not look like 90 degrees on this diagram because this is a three-dimensional diagram on a two-dimensional surface. And we're also told that the distance AB is 174 meters as shown here, BC is 65 meters shown here as well, and AC is 226 meters. And the first part of this question wants us to calculate angle ABC. That's the angle right here. Angle ABC is the angle right here. So let's call that angle alpha and show alpha on the diagram. So what we have is a triangle that is not a right angle triangle. We want to find alpha, which is inside this triangle. It's not a right angle triangle, and therefore we cannot use any of the three trig ratios, sine, cosine, or tangent. We cannot use any of those trig ratios. We have to use either the sine rule or the cosine rule. And to test if we can use the sine rule, we look for a known angle and a known opposite side to that known angle. We do not have that here. We know none of the angles here, and so we are left with only the cosine rule to work with. And we typically use the cosine rule when we have two sides and an angle between them in consideration. So what we have to do is use this and this as our two sides and alpha as our angle. So these are our two sides, and this is our angle between, and we're going to apply the cosine rule to find alpha, and this is it. We're going to be using the cosine rule, and using the cosine rule with these two sides and this as our angle between, we end up with this side opposite the angle 226 squared equals 174 squared plus 65 squared minus 2 times 174 multiplied by 65 multiplied by the cosine of the angle between the 174 and the 65. And here we have applied the cosine rule. And now since we want to find alpha, we can transpose to make this expression positive by bringing all of this expression over onto this side, and we can take this 226 squared over onto this side and subtract it. So that's just simplifying or rearranging this equation to make it simpler. And now that we have the cos alpha term on this side, we can divide both sides now by this multiplication here, the 2 multiplied by 174 multiplied by 65. When we divide both sides by that, the result is this. And so cos alpha is 174 squared plus 65 squared minus 226 squared, all divided by 2 multiplied by 174 multiplied by 65. And so we are dividing this numerator, all of this numerator, by all of this denominator. When we crunch these numbers, the result is negative 0.733, and so to find alpha, we need to take the inverse cosine of negative 0.733, and this is it. Alpha is cos to the minus 1 of negative 0.733, and so alpha is 137 degrees to the nearest degree. And so this angle ABC right here, this angle here is 137 degrees, and that's the answer for that part of the question. Let's move down now to the next part. So what we have so far is that this angle is 137 degrees, and we have the 3 sides of the triangle. Now we're required to find the area of triangle ABC, and here we can apply the trig formula for the area of a triangle because we have the sides and we have the angle between these two sides. So we can use the trig formula for the area of a triangle. We're going to call the area AT, and this is a reminder of the trig formula for the area of a triangle. When we have a triangle with 2 known sides and a known angle between those 2 known sides, the area of that triangle is half the product of those 2 sides multiplied by the sine of the angle between those 2 sides. And so we can use this formula for the area of this triangle because we have that situation. We have 2 sides and an included angle, a known angle between the 2 sides. And applying this formula, the area of triangle ABC becomes half 174 multiplied by 65 multiplied by the sine of 137 degrees. And so this will give us the area of that triangle. And this is it. The area of triangle ABC is this meter squared. So that is the answer for this part of this question. And let's move down now to part 2. Now part 2 tells us that the angle of elevation of T from B is 23 degrees. That's the angle of elevation from B to T is 23 degrees. And the angle of elevation is the angle above the horizontal when looking upwards. And we are required firstly to show that angle of elevation on the diagram. And this line represents a line of sight when looking upwards. Remember, this is horizontal. This line to the base of the tower represents the horizontal, and so we had to elevate the line of sight above the horizontal to form the angle of elevation here, and therefore that is the angle of elevation from B to T, the angle above the horizontal looking upwards to T. That angle is 23 degrees, and we have to remember that because this is horizontal, AB is horizontal and this TA is vertical, the angle between this vertical and this horizontal here is 90 degrees, and therefore what we have here is a right angled triangle. And if we isolate that triangle and take a side view, this is what we will see. A is here, this TA represents the tower, This is AB. AB is right here, 174 meters. The angle between TA and AB is 90 degrees, that's here, and the angle of elevation, 23 degrees, is the angle above the horizontal AB looking upward to T from B. That angle is 23 degrees. And so this diagram is a side view of what we have here. And now we are required to calculate the height of the lighthouse, that is TA. And so we can work in this right angle triangle to calculate the height of TA. And here we have this angle, we have the adjacent to this angle in this triangle. This is the 90 degree, and therefore this is the hypotenuse. And here TA is opposite to this angle, and therefore we want the trig ratio that will connect the opposite and the adjacent, because we are trying to find the opposite side and we have the adjacent side. And so the trig ratio to use is a tangent trig ratio. And so we start with the definition of tan. Tan of 23 degrees here is equal to the opposite side TA divided by the adjacent side, which is 174 meters. And this is it. Tan 23 degrees equals TA divided by 174. And if we transpose the 174 here by multiplying both sides by 174, we end up with TA being equal to 174 multiplied by the tan of 23 degrees. And that works out to be 73.9 meters. And so the height of the lighthouse, TA, is 73.9 meters. And that's the answer for this part of the question. And so that's the end of question 10, and we'll do our last question, question 11, in the next video. See you then.